Hey everyone, this is the first of two videos that we will be doing as practice. In this first video, we're covering our first learning target, 1.1, and this is conversions. I'm going to show you some dimensional analysis, and we're going to use it to convert from grams to moles to particles. And the next video that we watch, we're going to use dimensional analysis in converting from one substance to another. It's also called stoichiometry, and it's a pretty important topic within chemistry. What you'll need is a writing utensil. You'll need your calculator, and also you'll need to be able to reference a periodic table. Remember that we have one on the classroom under materials. You'll see a periodic table that looks like this. You'll also want a copy of what we're looking at right now, which is the 1.1 practice, either a physical copy, or you could be working on the digital one too that I've listed under the resources. So in this learning target, we're going to be converting from the three different substances, and I think it would help just to start off by showing a little diagram on the top here. I think this helps. We're going to be converting from moles of a substance. Let's call that moles of X. Now, you're not going to find an X on the periodic table because there is not an element that is X. X could stand for any element or compound, any pure substance. We can convert from moles of a substance to grams of a substance. We could also convert from moles of a substance to particles of that substance. Take a look at that for a second, try to make sense of that. We can convert from moles of X to particles of X. When I say particles, you should be thinking about Avogadro's number. We're talking about either atoms or molecules. The grams of X is pretty obvious, but moles, it's really just a collection of particles. Now, to convert from moles of X to particles, we need Avogadro's number. So I'll just write above this since we're doing it for the first time as a reminder that 1 mole equals 6.022 times 10 to the 23 particles. And that's regardless of what element it is. To convert from grams to moles, we would need to know our conversion factor is 1 mole equals some number of grams, and that depends on the periodic table. What we need to know is the mass of a mole. Another way of describing that is by calling it the molar mass of a substance. The spot that you can find the molar mass of a substance is on the periodic table. So let's find sodium on the periodic table. It's right over here, Na. And notice that number next to it. That is the average atomic mass of sodium, also called the molar mass. 22.99. What that number means is that for every 1 mole of sodium, of Na, it equals 22.99 grams. So I'm going to write that next to sodium here, 22.99 grams per mole. I could then do the same thing for phosphorus, finding phosphorus on the periodic table. And that has a molar mass of 30.97. like that. So take a moment and collect the rest of these molar masses yourself. Once you have them, we're going to use them and we're going to convert. So in problem number 2, it says find the number of moles for each. Let's do one that we're starting with grams, and let's do one where we're starting with atoms. First off, in this first one, we are starting with grams of aluminum, and we're asked to convert 2 moles of aluminum. I'm just going to get us started by rewriting the given information and getting the train track started. Now, I know that some of you can do this without doing those train tracks, the dimensional analysis part, but I want you to get in the habit of doing this because we're going to get to some more difficult problems, and if you have this down, it's going to make those problems a lot easier. So far I haven't converted anything. I have grams on the bottom, and I have the unit canceled, but I don't know what to convert to. Let's look it up at our chart here. We have grams of X. We can convert to moles of X in one step. But in order to find out what goes here for the conversion factor, I'm going to have to look up aluminum and find its molar mass, the number of grams for every 1 mole of aluminum. So on the periodic table, here's aluminum, 26.98. So that's the number that goes here for every 1 mole. I'm going to follow through with my significant figures. I have 3 there, and my answer, rounded to 3 sig figs, is 2.38 moles of aluminum. 2.38, this collection we call Avogadro's number. Now let's convert from atoms to moles. Circling my given information. I know I need to convert it to moles. So I'm going to cancel my atoms on bottom, and notice that I can convert from atoms to moles in one step. That conversion factor, regardless of what element it is using Avogadro's number. Anytime we have a mole of anything, it's equal to 6.022 times 10 to the 23rd atoms. I have managed to cancel my atoms, and I'm left with the unit that I'm trying to get to. And I'll round to 3 significant figures. One thing I will tell you when you're dealing with scientific notation, in your calculator, put a parentheses around scientific notation, or else the calculator might get a little confused. And I get a value of with 3 sig figs, 0.500 moles of rubidium. Okay. Jumping down to number 3. Now we're trying to find the mass in grams. Let's try A, where we're going from moles to mass, and let's try C, where we're going atoms to mass. In A, we're going to start with 1.22 moles of Na. I'm going to cancel my moles of sodium on bottom. And I can go from moles I can go from moles to grams in one step. So I'm going to put grams of Na on top. And the number I use for this is going to be the molar mass. The same one actually that we wrote down right here. 22 grams per mole. So I'm going to 22.99 grams per mole. Before we calculate this one out, I'd like you to compare this problem here with this problem here. Take a look to see how they're similar and how they're different. Notice that since we're starting with moles on this one, we have to cancel moles on the bottom, and we end up with grams on top, which is the opposite of the last problem we did, the number 2a. In this case, we have to put the molar mass on the top side. When I multiply this through, I need to end up with 3 significant figures, so 28.0 grams of sodium. Okay, on to the next one. Let's jump down to C. We're starting with atoms of Ta. I'm actually just going to draw a line coming right off of this one. I'm going to cancel my atoms. You know, we always cancel the unit that we start with if we're doing a conversion problem, so that's a good way to start. And we're trying to convert to grams still because it's still part of question 3. Atoms to grams. Now, this is the first time we've seen it where it's going to be more than one step. In order to get from atoms or particles to grams, we're going to need to go to moles first, can't skip moles, and then to grams. That's 2 steps. So I'm going to go atoms to moles. That's our first step. And then moles to grams. By doing that, we're canceling our atoms, canceling the moles, and we're left with grams. But I do still need to I need to put in those values, the conversion factors. First one is Avogadro's number. And the second one is the molar mass, which I'll need to look up on the periodic table. We're looking for, what element was it? Oh, Ta. Okay, which is not a very common element. One of our transition metals here. 180.95. Don't forget about your parentheses when you go to plug this one in. And with, let's see, we're going to round this to 4 sig figs. And that would be 1810 grams of Ta. And you might have noticed by this point that you can check your answer because I have them in the parentheses afterwards. Okay, we're going to do 2 more problems. I'm going to leave the rest for you. We haven't done one where we're converting to atoms yet, so let's convert from moles to atoms and from grams to atoms. Starting with this one where we have moles of bismuth. I don't know what happened there. We know we need to cancel our moles of bismuth. Trying to get to atoms. That is a 1-step process. moles to particles, one step. If this were a compound, instead of putting atoms of Bi, I would put molecules. And that conversion factor is 6.022 particles, in this case, atoms, for every 1 mole of Bi. Canceling my moles, I'm left with atoms. And that gives us 6.046 times 10 to the 23rd atoms. I know it says 6.044 here, but that is not the answer I get when I plug this in. Last one of these, let's start with 54 grams of aluminum. And we're converting to atoms again. This is our 6th option for converting these. If we're going grams to particles, that is going to be a 2-step process. So I know that I'm going to need 2 steps within this to get this done. In the first step, I'm going grams to moles. And in the second step, I'm going moles of aluminum to atoms. Put in Avogadro's number for every 1 mole, and put in the molar mass of aluminum, which we can find, or which we've already found right here, 26.98. That allows us to cancel grams of aluminum, canceling moles of aluminum, and we're left with atoms. I got an answer of 1.20. That's 3 sig figs. 1, 2, 3 times 10 to the 24th atoms of Al. Okay, I will post a key for this. Oh, I'd like to point out one other thing. What do you notice about the number that's next to moles for all these? I hope you notice that every time we deal with moles, we're always talking about 1 mole. 1 mole, 1 mole. And that's because we're either talking about the molar mass, which is grams in 1 mole, or Avogadro's number, which is particles in 1 mole.